In our next question, I want to talk about how we can use regular expressions effectively from Python, looking just at the Python use case. This question is titled, how do I use regular expressions effectively from Python? And I want to talk about the RE library. I want to talk about some alternatives to the RE library, the PCRE library and the RE2 library, which are third-party supported libraries. And I want to talk about some common strategies that you might run into. One strategy is this. Multi-line matches and complex matches with back references and look ahead and look behind assertions, they get really difficult for you to make sure that they're correct very quickly. And there may be cases where you need to use them. You need to put all the computation in the regular expression. But to a large degree, what you may find is that you may just use regular expressions for the broad strokes to just extract the broad strokes of a matching line and then dive into that with another regular expression match in Python or with some string mechanics. And so one of the things that I think about if I'm trying to match is I try to think, well, how can I break this problem down so I can write the simplest regular expression possible? In this case, this kind of matching is going to be kind of tricky because the values that I want to match are going to span over multiple lines. But if it were the case that I could say, oh, I'm matching, some value equals some, or some variable name equals some value, and I want to ignore those comments and I want to ignore that hash, and the entirety of the information I need is in one line, then what I probably would do is avoid using findIter because that's going to create maybe a more complex regular expression that I need, and instead use Python to split it into lines and then perform the matching within the lines. And you can see when I do that, this mostly seems to work, except this portion here doesn't seem to work. It's not capturing the comment correctly for those lines. So I have to tweak it a little bit. Now, what would I really do? In practice, do I want to work to get this thing to, do I really want to play with this to get this thing to work correctly? Let's see, does that fix it? No, maybe what I'd do is I would just remove this portion and I'd make this the value and comment, and then use another regular expression to dive into this portion, or use some basic string mechanics in Python to dive into this portion all by itself. Rather than making one giant regular expression, I can work on this piecemeal. I can extract with large strokes some part of the text and then whittle it down to the portion that I want. And that may in practice be more effective than really struggling with this regular expression to get it to work. Another thing that I might do along the way is I might make use of these regular expressions being some sort of string and template them and build them up. And so here you can see an example of me building up a regular expression that hopefully I can debug later by specifying what the pattern is for the variable name, the pattern is for the value, the pattern is for the comment, and then say the pattern is for the single line. It's a variable name, an equal sign, and the pattern, the value, and then a comment, an optional comment. And this may allow me to break these down a little bit more easily and potentially even debug these or reuse some of these portions later as part of this whittle down strategy. Because one giant regular expression, it's going to be very hard for you to debug. It's going to be very hard for you to read. And you're really looking for strategies to effectively extract this text. Probably what you might do is broad strokes with a big, not that smart regular expression, and then a couple more purpose-fit regular expressions with a little bit of manual string mechanics in Python. Now, I can make this a little bit more complex. You can see here I have either numbers or text, and I could break this down further. And you can see here something that's not too uncommon in cases where I want to use regular expressions to break down these simple line-orientated data. Here, I say there's a variable name pattern. There's a number value pattern, which is just any number of digits. There is a string value pattern. This has my kind of fancy double quote, single quote string matching. And the value pattern is either a numeric value or a string value. The comment pattern is, one of those comments, and I build that up into my line regex. And you can see how I'm starting to kind of build up these pieces. And here you can see, okay, for each one of these, I was able to extract, the whole part of the value and the string part of the value, or for the first case, the whole part of the value and the numeric part of the value. And you can think what I'm building here is a very simple parser. At the point when I do this, I really should be thinking, do I really want to reach for a proper parsing tool? Is it more appropriate for me to reach for a parsing tool? But there may be cases where, by whatever restriction that I have, I really just need to have one giant regular expression. Well, at least I can make use of some of these string manipulation, F strings and things like that to make it more readable in Python. So I tend to write these regular expressions as small pieces that I can test independently and then assemble them with F strings. This tends to be a very common pattern. Now, I want to talk about the RE and the RE2 module. There is a third-party module called RE2, and if you use it, you will notice that for simple regular expressions, it is actually notably slower than the built-in RE module. You might wonder why anybody uses it. And what you might notice is the RE module seems to have some interesting behavior with certain types of patterns. With a pattern like ABC, you can see it's giving you, I'll show you the comparison. Here, it's giving you an RE2 pattern instead of an RE pattern. But if I change this pattern very slightly and I include that back reference, or that reference, you can see it gives me a Python RE pattern. And if I do the same thing with this other reference here, see it gives me a Python RE pattern. Well, the RE2 module gives you the ability to take certain backtracking-free regular expressions and to compile them to much more reliable, more robust, and constrained performance versions, or if it contains some of these patterns that are not capable to do in a more efficient fashion, to drop down into the regular RE module. So largely you can think of the RE2 module as something like a drop-in replacement for the RE module, where certain fast paths exist for certain types of patterns. And the critical type of pattern that we're talking about is what is called catastrophic backtracking. If I have a pattern like this, any number of A's, one or more A's, then one or more A's, and then a B. What the regular expression language is going to do is going to try and match A, then any number of those, and then the B. If it takes to the very end to find that B, it's going to start rewinding. And it's going to rewind by saying, oh, I took too many of the first group. Let me try taking one less and then try again. I took too many of this group. Let me try taking one less and try again. And what you'll see is, in the case of an actual match, it's very fast. But in the case of no match, this is catastrophically slow. For a string with 25 A's but no B, it takes over a second to fail to make this match. Because with this backtracking-based RE module in Python, what's going to happen is, if it can't find the match, it's going to go back to the last alternation point or the last quantification point, and it's going to take one fewer character and try again. Take one fewer character and try again. Take one fewer character and try again. And you can think as this starts getting longer and longer and longer, the number of possibilities it's going to try is going to explode. This is what's called catastrophic backtracking. And if you think about it, if you're accepting regular expressions from your end users, they could craft a regular expression. Like if you have a search and replace for some data platform that you create that allows people to find data sets by name, you allow them to put in regular expressions. A malicious user could craft a catastrophic backtracking regular expression which takes down your site because it takes too long for it to process. Because think about this. If this thing is 15 A's with no match, it's relatively fast. If it's 25 A's, it starts getting really slow. If this thing is 50 A's, this session will be over. This video will be over by the time this finishes computing. This gets very, very slow very quickly. It is catastrophically bad. One of the main reasons why we might use the RE2 module is it's fast in both cases. It doesn't backtrack. And because it doesn't backtrack, you no longer have this risk of catastrophic backtracking with regular expressions that were either maliciously malformed or were formed in order to or accidentally malformed, where there's some backtracking that's forcing it to try and reevaluate and reevaluate and reevaluate. And this is why this RE2 module comes down. And if you need some behavior that does require that backtracking, the RE2 module drops down into the regular RE module.